starting from session 1 to session 9.
Okay.
Yeah. And we do this together.
First question. What turnover time would you recommend for a residential pool in hours? Is it A, 1 to 2 hours, B, 4 to 6 hours, C, 6 to 8 hours?
And the answer is
B.
Yeah.
Perfect.
B.
Look at that. We have 14, I think. What is that up there? 14.
Yeah, so yeah, we didn't mention
This is
that.
great.
Oh,
Yeah.
yeah.
We were
maybe.
not able to do this live poll because it's limited to 10 questions and we have 30 questions.
Yeah.
So,
So-
that's my fault. Sorry.
He can never keep it short.
Yeah,
Right.
yeah.
So,
Sorry for that.
yeah.
And it's 1 to 2 hours is not wrong, but yeah,
Yes.
you always have to find the compromise between what you can pay and what you cannot pay.
Yep.
But could we see the chat at the same time we answer, or
I don't think so. Well, maybe, huh?
just to, I mean,
Let's go to the
Yeah,
chat
yeah.
in the end.
Yeah.
Otherwise,
So you
oh
do-
yeah,
Okay.
yeah, good.
You
good.
don't need to use the chat. Yeah.
yeah, so here
Okay.
you see, okay. Yeah.
Uh-huh. Good morning, Jersey. Yeah.
Yeah.
Yeah, but it's a little bit
You don't
small.
need to
I don't have
use
my
the
glasses.
chat, huh?
No, no, just answer this. It's
For
we do
yourself,
this together. It's
in the group you are,
yeah,
exactly.
self-test.
Huh?
You know, it's a little
It's for
bit
you.
summary,
Yeah.
Yep.
recalculation where we have to be.
Okay.
Number 2.
How many cycles per day? Turnover cycles per day. A, 1 to 2. B, 3 to 4. C, 5 to 6. Remember, residential pool. The answer is
There is nothing coming. Oh, I don't have the control anymore.
there you go.
Here, B.
B is the answer.
5
Okay.
to 6 is not wrong. You know, 1 to 2 is a little bit too small. So in a real case scenario, you know, cost efficiency, 3 to 4, you're really okay.
Mhm.
Okay. Remember, this is the summary, you know, from session number 1, where we said, okay, ideally you have a turnover time from 4 to 6 hours. Small pools, heavy loaded pools, more something like 4 hours. If you have big pools like 100 cubic meters, 6 hours is acceptable. Use a low filtration velocity during nighttime. Control it with Flowys, right? And go in a 30 meters per hour filtration velocity during daytime. Make 1 or 2 cycles, and then another 1 or 2 during nighttime.
Yep.
Don't forget to do the stack arm piping. That's all in session number 1.
Yeah.
Okay.
Okay. Now we're already in
Question,
session
so
2.
we're
huh?
in session 2. What is the recommended filtration velocity in swimming pools? 15 to 30 meters per hour, 10 to 20 meters per hour, or 30 to 50 meters per hour?
And the Oscar goes to A. Again, B would be even better, but cost and performance, 15 to 30, you're good. 30, this is according to Dean. If you can slow it down during nighttime, it's even better. Backwashing, very important. Next question.
For a proper backwash, what is the minimum
Minimum.
bed expansion needed? 5%, 15%, or 25%?
And the Oscars goes to B. 15 is the minimum. So there is no interpretation. 5 is too low. 25 would be the ideal one.
Yes.
Again, you know, talking about filtration velocities, you remember maybe this slide. Focus first on the yellow bar. The yellow bar, this is quartz sand. Here you see the performance of 5 micron filtration with 50 meters per hour filtration velocity, and you see this 30, and you see this is a huge difference.
And 50 would be all
And
the way.
50 is down here. You know, you can't filter any more 5 micron particles. It's just impossible. You see that the difference in AFM is less. Yes, that's great. But as we have seen, there are also other advantages that you can use.
Yeah.
And again, this is why we would recommend 30 meters or lower during daytime and 15, 20 during nighttime. Remember, you also need we have the very best software with AFM, but you also need a reasonable hardware. The blue one is a really good one.
Yeah.
Jan, do you agree? Okay, let's not make too much of promotion. They anyway have too much of orders. Yeah, that was a flacking in. And what comes in must comes out. It's like a
bin. Yeah.
you have
So
to empty it.
Yeah.
Proper backwash, minimum 15%, ideally 25%. That's
Yep.
what we have with AFM. Yeah.
Yeah, and this is what we have discussed here. And you remember, this is an IFTS. Here you see a 25% of bad expansion. This was when AFM was tested a couple of years ago. They made this video. This is how it looks like. You know, this is really what comes out. And now you also understand, you know, what's the importance of side glasses. And to do that, we need with AFM NG, with the new AFME NG, 40 meters per hour, can be higher, 40 to 50. With sand, depending a little bit on the grain size, you need 50 to 60 meters. You know, if you have big grain size like they use in Germany, 0.7 to 1.2, you need 60, 0.4, 0.8, 50. Why is there a difference?
Well, the difference would come from the density. So you have a lower density with AFM. So you have 1 cubic meter of AFM is 1,250 kilos, and sand it's 1,500 kilos.
That's 20% of difference.
Yeah.
And 50 to 40 is 20% of difference. I think there is a kind of logic in. Huh?
Yep.
Yeah, not all of these glass sands have a good bad expansion, by the way. Maybe we come to that.
Yes. So when it comes to backwash, fast and short is better than slow and long. You remember this, right?
Yeah, this is
So-
not in everything in
Yes.
the life. It's like this, but in backwash, this is what it is.
So-
Fast and short.
Again, for example, if you have a 2 meter distance from your laterals all the way to the top diffusers that the water has to travel, then if you backwash at 60 meters per hour, it will take the water 2 minutes to reach the top diffuser.
You got
Huh?
that? 60 meters per hour is in 1 minute, 1 meter.
Yep.
So what Philip says from here, from the nozzle plate or laterals to the top diffusers, 2 minutes. So that means this is the minimum time at that backwash velocity that you have to backwash your filter, and that you want to be on the safe side, you give plus 50%.
Yes.
So this is the number one here. Philip, you explain us?
So if you backwash at only 30 meters per hour, then this time will double. It will take 4 minutes for the water to reach the top laterals, huh?
Because this is a 1 meter in 2 minutes. That's the velocity or the speed of a snail. Turbo snail maybe, but yeah.
Yeah. So another reason is you want the particles to be washed out during
Yeah, but
backwash.
maybe because I think it's so important. And if you make the mass, you know, 4 minutes, and as we said, you know, plus 50%. So with 60 meters per hour, minimum 3 minutes. With 30 meters per hour, minimum 6 minutes. These are the 2 and the 4 minutes plus 50%. If you make the mass, how much of water it is, it's exactly the same.
Yeah.
No change.
Yeah.
So again, why should we go more to a higher velocity than, because water-wise it's the same.
Yeah. Yeah.
And the
Well,
answer
because
is,
you need to evacuate the particles that you filtered, right? And so especially bigger particles, they need more lift. So you need more filtration velocity,
friction,
backwash
yeah,
velocity.
more-
Yeah.
Yep.
heavy particles, heavy metals. So fast and short, better than slow and long. I like that slogan in a way. Okay, next question.
Questions. We're still in session 2, huh? Okay. Does glass media always perform better than sand? Yes or no? And the answer is no.
No.
We'll see this on the next slide, huh? Next question. What is the main difference between AFM and glass sand? Is it A, AFM has a higher bed expansion at the same backwash velocity? B, AFM only uses green and brown glass? C, AFM fully prevents the formation of biofilm in the filter bed? A, B, C. What is the main difference? The main difference is C. Yeah?
That's the most important. This is bioresistance. Of course, it's coming from the green and the brown glass. And of course, we have a better back. All is true. But the main difference, the key point is the bioresistant. This is for the question number 5. Is it always better glass than sand? You see here our famous 95% limit. You know, how fine can you filter with AFM NG1 down to 1 micron? Maybe this is why we call it AFM1, right? No. Okay, 1:1. Second best in class. IFTS results that we tested a couple of years ago, and it was really the best quality sand that we found in the UK was 20, and the next one was 25, and all the other glass sands were less good. So it's not always better. It's not always better. Flo, I miss here DGS.
Yep.
Our glass sand.
DGS, we really focus on AFM. That's why it's not in there. But we can filter 95% of all particles down to 10 microns.
10. So it's better. Now, honestly, these curves will all come down beside AFM, will stay where it is because it's fully bioresistant. DGS is slightly bioresistant. Sand is very bioactive. And on the glass that you see here, it depends a little bit how it's done, etc. But all of them will come down. Sand will come down. So yeah, is glass better than sand? No. Some of them are, and some of them are not. Huh? You want to take this?
Yeah. So yeah, most important, performance is one thing, but how long this will last, this is another one. And we don't want this loss of performance. And we see that sand is very subject to biofouling. Performance will drop faster than other ones, than other glass. And you lose your filtration efficiency over time.
Yep.
With green and brown glass, you naturally have these metal oxides that will prevent, not fully prevent, but prevent this bacteria from sticking onto the glass from this biofouling. So you will limit biofilm, and you will, the glass will last a bit longer. Performance will not drop as fast as sand.
So the good glass is the white glass, the green and the brown glass,
White
not
glass,
the white glass.
No metal oxides, not bioresistant.
We would love to use white glass because it's the cheapest, it's the cleanest that you can get. You don't have to color sort, you don't have to wash. You would save millions of investment, but it doesn't work. Yeah.
So
Howard started with white glass and it did not work, so that's why.
And the big difference of AFM is that it's fully bioresistant.
Yeah, which we get through the activation, because there we increased the surface dramatically. Remember, you have here the water with some oxygen producing free radicals on the surface. So it's a surface reaction. If you have 300 times bigger surface than DGS, you have 300 times more free radicals. This is why it's so much better. So if you want to go for the best, go for AFM. Okay,
so
we come to session number 2.
We're still in session 2.
Yeah.
Oh, still.
So,
Okay.
so here you have a pool
That
of
was a long session, huh?
50 cubic meter
Yeah.
pool, turnover rate 5 hours. So you have a flow rate of 10 cubic meters per hour.
Remember the 4 to 6, average is 5.
Yeah.
It's also easier to calculate.
And here the question is, which filter do you have to choose if you want to have a 30 meters per hour filtration velocity?
Approximately 30.
So I helped you with mentioning here the filter surface to help you. So A is 520 millimeters, B 640, or C 720.
Or D 840. Or F 960.
So flow rate 10 cubic meters per hour.
Okay.
Okay, the Oscars goes to B.
B, Y.
Yeah,
yes.
and here you see the calculation.
You take your flow rate, you divide it by your velocity, and you get your filter surface.
Yep.
Yeah, and that should be in your manufacturers, or you calculate it. Let's do it. Next one, Philip.
Yeah. So what flow rate do you need to backwash a 1600 millimeter diameter filter at 50 meters per hour?
You see, we are now in the king size discipline in the public
so
pools.
yes.
So filter 1.8 in diameter. Now you have
1.6
1.6
diameter.
Sorry.
So now
So first calculate your filter surface.
It's an easy one.
0.8 times 0.8.
Times P.
Radius,
P is 3.14, and then I don't know it anymore.
I know it.
Good. Tell us.
1415.
Okay, I can double check it. Okay,
It
the
is
answer
true.
is C. We want to have 15 meters per hour filtration velocity. We also could go to 40, then it would be A. But if you want to go to 50, this is the calculation.
So speed multiplied by filter surface, you get your flow rate.
Yeah. And because we all love calculation, everybody loves mathematics, I guess. Let's do one
Yeah,
more.
it's-
One more,
I
huh?
think it's not too easy. So
Yeah.
if you have a flow rate of 120 cubic per hour this time, what filters do you choose for 30 meters per hour velocity filtration? So A, one filter of a diameter of 2400, B, two filters, diameter 1600, or C, four filters of a diameter of
That's a real
1000.
case. That's a real case. Victor, in Russia, for example, you know, that was our 25-meter pools that you always build in Russia, you know, roughly for 480 cubic meters divided by 4. You know, if we stay with the simple formula, 120 cubic meter, what filters should you choose? And the answer is B or A. You can do both. You know, you have the 120, you divide it by the velocity, you get 4 square meters. Now you can take one big filter, 2.4 or 2. In Calpros it would be 2320.
Yep.
Which has 4.2 square meter, 2.4 is 4.5 square meter, or you go for 2 filters with 2 square meters, so it also equals to 4 square meters. Honestly, I always am a fan of having 2 filters. So you have a kind of safety net.
Yeah.
If something goes wrong, you still have half of the capacity.
Yep.
This is one of my main questions. If we reach you with this, then I'm very happy with this Pool Academy. I'm anyway happy. You know, again, the example that Florent did, you go for the 500 millimeter filter, the 600, the 720, and you see what small differences are between a 500 and a 600, and what is the impact on the filtration velocity. So please don't use 500 millimeter filter, and definitely not 400 millimeter filter. I mean, 500 is acceptable if you have a very small pool, but all the rest, hear me, go one bigger. I mean, price difference is 50 to 200 euros. It's nothing. If you don't do it, you cheat your customer, and you make your business smaller. Than It's a no-brainer. It's absolutely a no-brainer. So here, size matters.
Size matters.
Size matters.
Again.
Yeah.
Yeah.
Small difference in price can make a huge difference. Who takes this?
Yeah, here again, why is a proper backwash important? And, you know, when we talk about filter design also, why a viewing glass is important.
Yeah. And this goes especially to my friends in the UK. You have bad expansion with sand with 30 meters per hour. Okay, start to use side glasses, and then you can check if this is true or not. This is, by the way, with sand and with AFM, but especially with sand, good backwashing is so important.
And you control everything with this flow meter.
Yeah, yeah. And
So,
this again is how you do it. Go on 50 meters or 20 meters in nighttime. Go on 30 meters or 25 or 35. We just get the main message during daytime. And then backwash again, you need the 40 to 50, especially if you don't have a side glass. This is a must, you need it. And please use variable speed pumps. This is the 21st century. We are not anymore in the caveman ages, in the dark ages.
Yeah.
Yeah. It's the Tesla. It's a Tesla of the pumps.
okay, we move to session
Yes,
3.
okay,
How are we in timing?
we have to hurry up a little bit. Okay, session 3. What is influencing the resistance? Remember the resistance. Is it A, the length of the pipe, B, the turbulence, meaning type and number of fittings, or C, the velocity in the pipes, or D, all 3 factors above?
And D comes from Dominic, from Dryden, no, from
Daisy.
Daisy. So D is always a good choice.
Yes,
the winner is
all
D.
3.
All the 3 are important.
Yes.
And next one.
So if you double the velocity in pipes, what will happen? A, the pressure loss will double. B, the pressure loss and the power consumption will double. Or C, the pressure loss will increase by a factor of 4. And the answer is C.
C. And again, remember this session, and I think it was one of our top 9 sessions.
Yeah.
No, I think it was really one of our top 3 sessions. It was a really good session. If you haven't seen it, go back to this. This is where we said, I mean, all comes from the speed, but it is it's a question, of the length of your pipe, how many fittings you put in this. This is important. You can't go with the theory, this is my bottleneck here. My pump has 1.5 inch, so I stay with 1.5 inch. No, it really depends how much of length, how much of fittings you have. Go big. Use these velocities, and then you are okay.
Mm-hmm.
Remember, different fittings have different pressure loss coefficient. This one has a higher one than this one. This is the absolutely killer, but it's then again influenced by the velocity that you have in these fittings. Because you create more turbulence. More turbulence means more resistance. Really important session. Go and look. It has nothing to do with AC, but it's really important. And remember, here we made one example, where you had the pipe lengths and where you get the different pressures, and then you had 20 fittings, and we calculated it once with 1.5 inch and one with 2 inch, and you see difference is 300 millibars. 300 millibars. Now you can say, what the fuck you care about 300 millibars? 300 millibars you see here. You can go one pump smaller. You can go to delta 13 instead of delta 17. You save 200 watts, and 200 watts multiplied with 24 hours, 150 days, that's 180 euros. The extra investment for this pipe is nothing.
And this is with Swiss price.
This is with Swiss price. That will be in Italy, half of it. So forget about 1.5. Always go in private pools to 2 inch or higher. If you don't do it, you cheat yourself and you cheat your customer. That's not what we want. Sorry, that was again a little bit emotional. Yeah. Last thing here. If you double the speed, your energy consumption increases by a factor of 4. Your resistance, and with this, your energy consumption.
Yes. And remember, the most sophisticated tool on the planet, the Dryden Aqua calculator.
Magic ruler.
The magic ruler.
And you can get one of these if you want to get your certificate.
Yes.
And beside that, call your Euraco in Italy and PS Pool in Spain. They have them from us. I hope they're not selling it. We give it free of charge. But they're much more expensive. I thought they were 2 euros.
They're
not. They're 10.
Yeah, I know.
Okay,
I know.
12.
We move to session 4.
Yes.
Question 12. Consequences of biofouling in the filter are A, channeling and loss of filtration performance, B, breeding ground for pathogens, C, conversion of urea to ammonia in the filter bed, or D, all three above. D, remember, D is a good one. Huh?
D is always
D
a good
for
one.
Dryden Aqua.
D for Dryden Aqua.
Good.
Okay, so all of them are right, huh?
And with AFM, you will have less of organic combined chlorine, inorganic combined chlorine, or total combined chlorine.
That's a tricky one, actually. Huh?
It's a
You
bit
have to
more
think about
difficult
it
one.
for a split second.
These are the
B, inorganic. We have less of inorganic.
Absolutely.
Total combined is the same. Organic, we have more. Again, quick look in this. What we said, this was because of question number 1, channeling, biofilm building, conversion from urea, again, organic to ammonia, this biological conversion, which goes then in monodi and trichloramine, which are the inorganic combined chlorine. And if you have an AFM, urea stay urea, 80% is urea from urine and from sweat. These will not be converted to ammonia. So these will also react to chlorine with chlorine and will create an organic chloramine. So that means if you have a AFM system, 80% of your chloramines are organic. And in the sand, it's just the opposite, 80% are inorganic, right? Now you can say, who cares? That's not important. Yeah, for the health department, it's not important, but of course, from a health point of view, it is important because trilamines, remember, they gas out and they are not good.
Okay.
Not good.
We have arrived at session number 5. Why is AFM NG better than AFM standard for pools? Is it A, it filters finer particles, B, it filters more organics from the water, C, it offers better backwash performance, or D, for Dryden or Dominic, all three above?
Yeah. Wow.
We knew it. Huh?
You made it quite easy.
We knew
Florent
it.
did it. Well, we did a little bit together. Next question.
What is the perfect layering for AFM-NG in small filters?
So for your all your AFM that you get now,
Is
yeah.
it 50-50, grade 1, grade 2? Is it 60-40 or is it 70-30? Perfect layering is A, 50-50.
yeah.
Okay,
All
why
stars.
is this? Do we
Yeah,
have a,
let's
we have,
have a
okay, we
look.
have one more
Yeah.
question here.
Okay,
Okay.
and this is
is
a
for
little bit
you.
more
That's
funny
yours,
one.
that's yours.
What is the Estée Lauder factor? It's a measurement of how expensive and difficult Dominic's wife is. I think that's my favorite. An indicator of filtration performance, a factor to show the extra cost of AFM in real life term. So it's C or A. Remember first for the layering, it's really the 50-50. Why? Because we changed here the grading, remember, for 0.4 to 1 to 0.4 to 0.8. So we made it smaller, more narrow. Grade 2 is now, with the NG activation, became really a hybrid. It's support and filtering in both.
Yep.
It's filtering better than sand, just the grade 2. So you have, with the 50-50, you have the same outstanding filtration efficiency as with the layering before. You have an ideal bed expansion, not too high. You will not lose media, or not too much, a little bit maybe, and you have less of pressure drop. So that's the really one to use. If you don't remember it anymore, go to the session or watch on YouTube our layering
Manual video. Yeah.
Yeah, and this was a little bit funny story, with the Estée Lauder. Yeah, we just wanted to bring it for fun, Patrick from Spain told me it's great AFM, but much too expensive. We cannot afford it in Spain. So my wife forced me to buy 2 Estée Lauder. This is the cost, and I compared this to the extra additional cost of AFM. And we see, for a 600 millimeter filter, which is a standard filter, we are talking less than one of this shitty bottle. I mean, the bottle is like this, and everything in life is relative.
It's relative, yeah.
Nietzsche already said this, and even for bigger filters. So, yeah.
Okay,
Good.
Daisy, session 6.
Yeah.
I take over?
Yeah.
Okay, Daisy. So our Dryden Aqua integrated system was developed to kill bacteria in pools, or was developed to kill algae in swimming pools, or C, was developed to prevent bacterial growth in swimming pools. That's an easy one.
It's easy. Remember,
We're
we
not
are not
killers.
killers, huh?
We are lovers.
Yep.
Like Euraqua. I learned this from Euraqua.
Prevent rather than
Stefano,
kill.
we are lovers, not killers. No,
Okay,
we are
then.
lovers, not fighters. That was his word.
Okay. Okay.
So we are fighters, but yeah.
Okay,
Yeah.
maybe a
Let's-
more tricky question. APF. A, can be dosed directly into the pool. B, must be dosed using a constant flow peristaltic pump. Or C, must be dosed into a ZPM. So the
Answer
most
is B.
important is this one, yeah.
Yeah.
B, yeah.
Yeah. So please not take a big pump because they are cheaper pump for 1 minute and stop for 59. This is wrong. You could dose it directly in the pool, and then you stop your pool and let settle it down. Then you will have a dust on the floor. In few contaminated cases, you can do this, for high turbidity, but that's not what you usually do. And yes, you can, it's great if you use a CPM to dose it, but if this is not possible because your pump is not strong enough, dose it just in front of the pump or even into the pump.
Yeah.
ACO.
And ACO works as a stabilizer to protect chlorine from photoreduction, or increases oxidation in outdoor and indoor pools. Or last one, works only with chlorine. A, B, or C? That's A, yes.
That's A, because it increases oxidation in outdoor, but not in indoor pools. You need the sun. If there is no sun, you don't have the effect. And it can work also with other things. With peroxide, for example, it will
Works
also
great.
create free radicals. So all good. Again, this is our Daisy approach, AFM, most important step, bioresistance to eliminate the breeding ground. Number 2.
The use of APF, coagulant and flocculant, which takes the food away, so there can't be any bacterial growth.
No food, no growth.
Yeah.
And 3, ACO, we protect chlorine from the UV light, and we amplify this natural disinfection power of the sun.
Prevent,
So we-
not kill.
Yeah.
This is how it stands for, and I will not, We are not brainwashing you again. We are just the best, right? We will see that later on.
Good.
Let's go to the
Session
corrosion.
7, corrosion. First
We left
question.
all the oxidation thing. It just got too long.
Yeah, yeah.
But it's a good session. Go and watch it. It's a good session. But let's concentrate
Okay.
on corrosion.
So corrosion is caused by chlorides only. B is a function of pH, alkalinity, total hardness, water temperature, and chlorides. Or C is a function of chlorine concentration. The answer is B.
Yeah.
All five
Huh?
factors.
So
All
all
five
five
factors.
factors, huh?
And then the LSI.
Okay, the LSI, Langelier Saturation Index, is an LSI of 0 shows the water is in balance. B, an LSI of plus 0.4 shows the water is corrosive. C, the best variable factor to adjust is the chlorides. And the answer is A.
A.
Huh?
Yeah.
So
because minus 0.4 shows that the water is
Yes.
corrosive. And yeah, chlorides play a role, but it's not the main role. It's really the pH which is important. It's the temperature. The lower the temperature, the more corrosive. The lower the pH, the lower the total hardness, the lower the alkalinity, and the higher the salinity. And actually, really, what you can change, because if your customer says, I want to have 25 degrees, he wants to have 25 and not 55. So this is not something you can change. Total hardness, also a little bit of tricky one. Salinity, it's not making such a big difference. It's really the alkalinity where you can play.
Yeah.
So Eudaqua and all my friends out there who are selling Bayrol, Alkaplast, that's a product to use. And, forgot that. This is in balance. You are here. If you're less than 0.4, you're really getting aggressive. If you're more than plus 0.4, you're getting scaling. So calcium formation, etc. Huh? This is really important for
Use the
for-
calculator, yeah.
Yeah.
Use the calculator.
Session 8, public pools. That was also a very good one in the top 9 of our sessions.
Oh, yeah. Top 3.
So public pools, with a sand and an AFM filter, you have approximately 80% of your inorganic, 20% of organic chloramines. This we discussed. B, you find the highest combined chlorine concentrations in outdoor pools. Or C, the sun is a very strong UV unit.
Okay,
That was
C.
C.
Why?
Well, the other ones are wrong.
Yeah, exactly. Yeah.
That's,
80% inorganic chloramines is for sand filters, but not true for AFM filters. There it's 80% organic chloramines. And what is the highest combined chlorine? Yeah, outdoor pools have the lowest combined chlorine because you have the sun, big UV system and free of charge. Okay.
Yeah, still in public pools, but this time indoor pools. A, the best way to reduce total combined chlorine is UV medium pressure. B, 10 centimeters of activated carbon on top of AFM is enough to bring the total combined chlorine from 0.4 to 0.2 ppm.
To below 0.2, yeah.
Or C, when you increase the layer of activated carbon to 30 centimeters instead of 10, you reduce the combined chlorine even more.
So as we do not have D, we have to think about, so it's B, it's really this 10 centimeters layer of activated carbon. This is what we had before. Remember, if you have here the sun is such a strong UV, it will create free radicals. If you add ACO into the water, it will create even more free radicals. This is a catalyst, will protect the chlorine from the sun, but you will have never problems with, usually if you have a problem in an outdoor pool with combined chlorine, then something is seriously wrong. So that's not the problem. It's really the indoor pools because you don't have the sun. So you're missing this. And what Florent explained us, the best is just to add a 10 centimeters layer of AFM. And that
activated carbon, yeah.
And then you don't have problems with biofouling because you still will have chlorine after this 10 centimeters. You will lose roughly 50% of the chlorine, but you will still have chlorine that will create the free radicals on the surface of the carbon. If you make here 30 centimeters, 50 centimeters, you lose all your chlorine, you get biofouling. You will not absorb more of combined chlorine, maybe in the first 2-3 months, but when it becomes a biofilter, it will go the opposite. So
And
this
you
is,
lose all your chlorine. And
yeah,
So more is not better.
no. These are great systems. We don't talk too much. This is the high ozonization system with the reaction tank and then the sorption filter. Mainly we are using this in Germany and Switzerland, so let's stay on this. This is something that you use a lot in the UK, you use a lot in Spain and US and in Italy. The UV medium pressure, again, it works, it brings combined chlorine down. We are not fan because of two reasons. One is THMs. You produce chloroform, and this is the most toxic one that you can do for everybody.
I just learned that in France, they only control THMs when there is a UV medium pressure installed.
Okay, surprise,
So
surprise.
it must be linked in.
Yeah, 10 years ago, you know, the UV industry said, yeah, that's not possible. Howard is wrong. No, Howard is right. Sorry to say. And also you're creating nitrate, you know, which is not good for algae, but that's not the key one. This is why we are really against. And this is why, besides, we have developed a new technology, you know, for the people who say, Dominic, I don't like this carbon. I don't like this. And this is the Advanox.
Yes, session 8.
Yes, session 8. So Advanox stands for advanced oxidation, which is peroxide is split into hydroxyl radicals with a UV greater 5,000 joules per square meter.
Which is massive.
Which is massive.
12 times more than in water, drinking water treatment. Yeah, sorry.
So I think the answer is A. The total pool volume needs to go through Advanox every 2 to 3 hours. Not days, hours. C, with Advanox, the use of activated carbon is a must. And the answer is D. For Dominic. No, it's A. Okay.
Yeah, it's A. Here, you have to go through the Advanox every 2 to 3 days. I mean, you could do it every 2 to 3 hours, but then it's becoming quite costly.
No need.
And then you don't need carbon. You really don't need carbon. This is instead of carbon. If you add it, I mean, you can do it, but that's not.
You gave the answer.
Shit. Yeah. This is,
Okay.
I helped them.
Yeah,
because that's a D.
It's a D.
Maybe they didn't see it, but okay. So Advanox works with sand filters, is also oxidizing pharmaceuticals and cosmetics, is great, but has higher running costs than UV medium pressure. Or D, Advanox is increasing the formation of THMs. Nadine, what's the answer?
Usually it's simple. D is always right? But
yes.
Not this time.
Not this case.
Not this time.
It's B.
So this was a kind of trap.
Yes.
So it's B. It does not work with sand filters. Remember, it does not work with sand filters because sand filters will have 80% inorganic combined chlorine, and the inorganic combined chlorine can build up very, very quickly. AFM gives us only organochloramine. They're built up slowly. That's why it's enough to go through the Advanox in this bypass every 2 to 3 days, not hours, 2 to 3 days.
Good.
And of course, it's not increasing THMs. This is UV medium pressure, which does it. It's after here, you know, after here, you have pure water. I mean, you have complete oxidation. We produce a massive amount. It's not like with the DHN or with the ACO. You produce in here a massive amount of free radicals. That means these free radicals will oxidize each and every bond, you know, of your molecules. So here you end up really with pure water. Even cosmetics, pharmaceuticals, they are gone. Okay, only 1 or 2% of the pool volume. But if you do this all the time, you get...
Wow.
We get to the very best solution. There is nothing better.
Session 9?
Last session, yeah. Session 9 was about pathogens. So question 29, we're almost at the end. A, in all countries, the same pathogens are tested. B, Legionella are the pioneers of biofilm. They are building up the biofilm. Or C, Pseudomonas are easily oxidized if they are planktonic, but not when they are protected by biofilm.
We hurried so much up, huh?
Yeah,
now we are a little bit, we are good in timing. It's C. In Italy and Spain, they test Pseudomonas. In Germany, they test Legionellas. That's what where their focus is. In the UK, it's crypto. So it's not in each and every country, it's the same one which is important. By the way, I think Spain and Italy is quite right because Pseudomonas are the pioneers. If you have the pioneers in, you have the biofilm,
Not the
then you have the problem.
Legionella, yeah.
And it's not the Legionellas, it's the Pseudomonas which are the biofilm. And Pseudomonas, again, if they are planktonic alone, you can easily oxidize them, but not if they are in a biofilm.
What is the best solution to prevent them in pools? A, use a fully bioresistant filter media. B, use a ZPM static mixer after the sand filter. Or C, remove all phosphates out from the water, the pool water. So
To help you, all solutions are good. But the best one is,
for prevention, yes.
yes, it's the bioresistant filter media. This is where all it starts. You know, the CPM will kill crypto after that, or at least damage them, will break up biofilm. Better not to even to have them. And of course, yeah, to remove phosphates is always a good thing, you know, especially if you have high phosphates level, but yeah. And here we get a bonus question.
Yeah, the last one.
Who gets the
take it.
bonus?
Okay, if you have pathogens in your pool, what is the first thing? So number one thing to check: A, check phosphates concentration. B, check chlorine concentration. Or C, check if the filter is biofilled and if backwashes are done properly.
Is there a D?
There's no D.
There is no
Lavender.
D, so it's a difficult one. Yeah, check really. I mean, if you have pathogens, usually it's come from the filter, and usually it's coming from inappropriate backwash problems, and you will have this. I wouldn't say it's impossible to have it with AFM. If you really lousy backwash your filter, you can have problems too. If you backwash them reasonable, you will never have the problem. Phosphates is of course also something that you could check. And go to session number 9 if you have pathogens in the pool. We also say how you can cure it with Triox. We even show it. You know, you remember where we had the doctors, the white coats. Yeah. So it's really about these pathogens. It's the Pseudomonas who are building up the biofilm. Then you have amoebas. With the amoebas, you have Legionellas. If you don't have biofilm, if you don't have Pseudomonas, you don't have a problem. So no biofilm means no pathogens. Yeah.
Yep. Perfect.
And especially in warm water pools, you know, this biofilm goes, how do you say this? What we learned now from the viruses goes exponential.
Yeah.
This is really exponential.
Yeah.
Vitamin D. What's the vitamin D?
Well, vitamin
So
prevention is
we're
better,
talking about the immune system, right?
Yes.
What makes a strong immune system is for our bodies is vitamin D. It's one important factor.
Yeah.
And
Your vitamin D for your pool is Daisy. That's your vitamin D for your pool. That really gives you a very protected environment. Yeah, that's really prevent rather than kill. Gives you the clearest water and also the safest water. And here we really talk about pathogens. All in session number 9. Yeah, Flo,
Please. Yes,
You
that's
get the
my
lead.
part. I get. Yeah,
you
I
get
guess.
the lead.
so maybe I have one bonus question.
Yeah,
you
tell
know,
me.
who was the best presenter? Was it A, Dominic, B, Florent, C, me, or D, all of the above?
Good
Yeah,
one.
Okay.
good. Yeah, good bonus question.
Yeah.
So you can write your answers in the
Or
chat,
maybe